Hello, welcome. Today we're going to look at functional and non-functional requirements. So last time you started on your requirements document, and today you're going to keep going with it. Actually, I don't think I made the assignment live yet, so I'll have to do that in a second. But let's keep going with how you're going to continue work on your requirements document, how you continue breaking it down. So last time we looked at user requirements and system requirements. Today we're going to split our requirements up further into functional and non-functional. So what's the difference between these? Let's get right to it. Functional requirements are actual statements about what the service should do. So these kind of relate a little bit back to user requirements, and it might be kind of tough to understand the difference. But you can have a user requirement that is non-functional. You generally don't. Generally your system requirements are going to be all non-functional. And then you could also have a system requirement that's functional. And generally you won't, but it is possible. But functional requirements describe what the thing does. So going back to a toaster, I said that the top level user description of a toaster is that, well, it toasts bread, and that is a functional statement too. The top level functional requirement of the toaster is that it toasts bread. A non-functional requirement for the toaster might be something like that it doesn't burn bread. So non-functional requirements are more like constraints on the service or the functions that the service offers. So other non-functional requirements for a toaster might be that it doesn't burn your house down, it doesn't explode, it doesn't emit any smoke, it doesn't consume more than a certain amount of electricity, the surface of the toaster doesn't get hot beyond a certain point. And some of those you could phrase as user requirements too, like the toaster not getting hot. You could express that as a user requirement as well. So there's an example for you of something that's both user and non-functional. So the basic principle, again, is that the functional requirements, they say what the system does or shouldn't do. So it doesn't necessarily have to be something that it does do. It could be something like doesn't get hot. And the non-functional requirements are constraints on the system. And those constraints usually derive from the functional requirements. So typically you have non-functional requirements following your functional requirements. What the system needs to do or not do, and then what are the constraints that get it to do that or not to do that. So functional requirements describe the functionality of your system or your services or whatever, depending on the kind of software it is, expected users, and the type of system where the software is going to be used. Software user requirements could be very high level, just like our previous section said. Functional system requirements, though, should describe the system services in detail. So the difference between your user requirements and your functional system requirements is that they have, obviously, that less natural language, more specific, more contractual, more detailed. Whereas your functional user requirements, they can still be abstract and in natural language and in clear statements for anybody to read. So you can further break down your user and your system requirements into functional and non-functional. I'll give you an example template for how to do that in the assignment today. But let's look at an example for the MentCare system. So some functional requirements based on that. A user shall be able to search the appointments lists for all clinics. The system shall generate each day for each clinic a list of patients who are expected to attend appointments that day. You can pretty much remember these all from the previous Tuesday? Each staff member using the system shall be uniquely identified by his or her 8-digit employee number. That kind of sounds like a constraint, so that one is maybe non-functional. It's kind of on the fence, and it's maybe not the best example, but it is still something that the system does, and it's still a high-level description of it. So when do we run into problems? A lot of you got some negative feedback on your requirements documents for being too vague. And the reason that I'm going to be particularly hard on you for being vague is because that's where the main source of problems in requirements originates from. Remember, your requirements document, if you're some kind of third-party contract like we're pretending to be, well, it's essentially contractual between you and the organization that you're doing the work for. And if it's contractual, then obviously being vague is going to be a problem. But there's also problems in terms of planning your development when you leave functional requirements imprecise. It's very difficult to plan the rest of the development cycle if your requirements aren't specific. Ambiguous requirements get interpreted differently by different developers too, and then different developers start building different things that end up not working together. So not only for the contractual reason, but also for the future developers who are going to inherit your requirements document, you need to be precise and specific, especially around your functional requirements, that is what the system does. So let's consider the term search in the first requirement. What does the user intend when they say search? Well, the user probably means they want to look for a patient name across all the appointments in the clinic. But what does the developer mean when they say search? Maybe they mean that you want to search for a patient in an individual clinic and have the user pick the clinic first and then search. So even something as small as that ambiguity, what is the search space, that already opens you up to differences in how the final application is delivered, and maybe the customer not being happy with it or the user's not being happy with it. So your requirements need to be complete and consistent. Complete meaning they should include a description of all of the facilities required, so everything that your application is supposed to do. They should cover the entire system. And they should be consistent. If you have any internal contradictions, that's obviously going to be an issue. So you need to cover the entire system and avoid writing any kind of contradictions into your terms. And in practice, because of system and environmental complexity, it's essentially impossible to produce a document that is both complete and consistent for any software beyond the most trivial complexity. So completeness, well, that's an impossible goal in and of itself. You can never fully describe everything. And consistency, well, the more you describe something and the closer you get to fully, the more likely you are to have a contradiction. So just on the basis of probability, it's impossible to achieve this perfectly. You're still going to have to try to aspire for it here. Now let's get more into non-functional requirements and some examples. So these might be system properties and constraints like I/O device capability, something to do with your system, time, storage. They might be related to the particular language you're going to use, what development environment you're going to use, what development method you're going to use. Generally speaking, the non-functional requirements are the system critical ones, because something like the car can drive 60 miles an hour is probably the most important part of the car, because if you have a car and it meets its functional requirement, it drives, but it can't make it to 60 miles an hour, then it can't go on the highway, which makes it not a particularly useful vehicle, at least where we live. Or let's say take it down to 10 miles an hour. Well, it meets its functional requirement, it drives, but if it can only make it to 10 miles an hour, it's not a very useful car. So if your non-functional requirements aren't met, the system may be useless or close to useless, regardless of if the functional requirements are technically met. And then you can further break down your non-functional requirements into all these different categories. So this is something for you to think about. You could have product requirements, things like efficiency, dependability, and security. So efficiency, something like it takes no more than 10 seconds to run. Dependability, the system is online 99.9% of the year, so like uptime guarantees. Security requirements, the system meets CICA standards, or the system is encrypted with such and such. Usability requirements, the system is usable by an average adult human after no more than 1 hour of training, or after reading the tutorial or something like that. You could further break down your efficiency requirements into performance, like runtime, and runs within a certain number of seconds, or space, like fits within a certain number of megabytes, or runs on a particular cloud instance or something. You have your organizational requirements. Those could be something environmental, something operational, something developmental. So environmental probably not going to apply to most of your applications, but maybe you work in an ecosystem. And this doesn't mean, by the way, the environment like trees and stuff. It means like the environment your system operates in. Maybe you work in an ecosystem that imposes constraints on you. Like, I don't know, maybe you have to work within AWS, and AWS has certain requirements. You have operational requirements maybe at your organization, probably not going to be an issue for you, but maybe company code puts up some barriers that you want to talk about. Development requirements, maybe you have a particular development model that you want to use. We're doing Agile here, you could say that if you want. External requirements, so you might have regulatory requirements from your government or from the organization that's assigning you these tasks. You might have ethical and moral requirements that you want to take into account. You might have legislative requirements, so legal stuff, as well as maybe accounting requirements. You have to log the amount of time you've spent, hint, hint. Maybe safety and security requirements. Probably not an issue for most of your systems, but maybe there's something to consider there. Non-functional requirements, implementing them affects the way that you build the system. If the system has really tight constraints like it needs to run within a certain time, maybe you pick a more efficient programming language. If it doesn't matter, maybe you pick a less efficient programming language. If your files need to fit within a certain amount of space, maybe you have to compress them. If they don't have to fit in that amount of space, maybe you don't. All kinds of different things like that will determine how your system is architected. A single non-functional requirement might become really important. So let's say that you have a non-functional requirement that user data needs to be secure. Well, if user data needs to be secure, now you've generated all these other functional requirements, like users need to be able to log in, and users need to be able to, save their data or something, and you could say that users are unable to access other users' data. So all of these functional requirements that derive from the requirement for user documents to be secure in your system. We kind of already went over these, so I'll just skip them, but let's look at some non-functional requirements in MentCare. So the product requirement, the MentCare system shall be available to all clinics during normal working hours, so it's a time constraint. Downtime within normal working hours shall not exceed 5 seconds in any one day, so there's a performance constraint there too. Organizational requirement, users of the MentCare system shall authenticate themselves using their health authority identity card. Okay, so that describes something that the organization provides, this health authority identity card. So it's not part of your system, it's part of the organization, and you have to interface with it in your application. External requirement, the system shall implement patient privacy provisions as per blah, blah, blah. So that's some law, regulation, and you have to meet it. That's an external requirement. Non-functional requirements can be very hard to state precisely. If it's a law or something like the previous example, well, that's easy. But things like performance constraints, especially in advance before you know what you're doing necessarily, very difficult to determine what kind of performance constraints you're going to need before you actually start working on it in earnest. So the goal or general idea of writing your non-functional requirements, you need them to be verifiable. So you need to have a non-functional requirement that can be objectively tested in some way. Let's go back to the previous example. So available during normal working hours, really easy to objectively test that, right? If it's down, you haven't met that requirement. Downtime within normal working hours shall not exceed 5 seconds a day. Well, you can measure how many seconds it's down. If it's more than 5 seconds, you don't meet that requirement. Users of the MentCare system shall authenticate themselves using their health authority card. Well, if they don't do that, then you haven't met the requirement. You should see the pattern here. It's easy to objectively validate all these things. If there's no way to objectively validate your non-functional requirement, if it's not verifiable, then it's not a very useful requirement. Goals are helpful to developers also to convey the intention of the system so that the developers know what exactly they're trying to make when they get around to that part. Usability requirements, we already talked about this a bit, but another example here, medical staff should be able to use all the system functions after 4 hours of training. So unlike a non-functional requirement like medical staff, your average medical staff will be able to use the application. Well, that's less objective because who determines average? How do you pick them? A better requirement might be like a randomly selected member of the medical staff or should be able to use it, or like 1 in 10 members of the medical staff should be able to use it. Something like that. The more objective it is, the better. And after this training, the average number of errors made by experienced users, blah, blah, blah. The problem with requirements that are phrased like this is that, you obviously seldom have time to actually execute this kind of verification at the end of the process. It's more for the spirit of the agreement than anything else. You're probably not going to be challenged on this kind of thing unless it's a really big multi-million-dollar deal, but it's nice to present that you have some kind of objective metric that you're going to meet, even if you're not necessarily going to actually test it. So some other metrics that might play into non-functional requirements: speed, size, ease of use, reliability, robustness, portability. Feel free to look over this slide for some inspiration to things that you might add to your non-functional requirements. And I think we'll call it a day for the lecture now, and you can go ahead and get started with your further work on the requirements document. So take the one that you were working on last time, continue working on it. We're now going to add functional and non-functional requirements to it. All right, I'll see you in Discord.